A week ago, it was a nice sunny day outside. Again, we've had two decent springs in a row in Wisconsin. At the same time, where we can't do as much as we used to, so it's kind of ironic. Usually in Wisconsin, our winters last well into April. But this year and last spring, we've had normal springs, of course, during a time when we can't do as much as usual. So, yes, cruel ironies could be proof of God. Anyway, it was a nice day last weekend, so I decided to take a Goodwill trip. I went over to Verona Road, Fitchburg, and Verona itself, and the Verona Goodwill finally had some good stuff. I've never found anything worthwhile there before. I got this click pedal. I actually need this for another project I want to do. Hopefully I'll have to do that soon. There's always school glue or glue sticks at Goodwill. I use these for my printers, so these are always handy. A little power bank. Rip this apart and get the circuit and the LiPo out of it, so why not? It's actually pretty heavy, so it's probably like 3,000 milliamps. But this is the cool thing. Some sort of magic touch screen. I'm thinking this was some sort of touch screen adapter for computers back in the 90s. It was $8, and I'm like, oh, I have to buy this. It definitely seemed like something that would be like an LGR. Maybe I can do an impression of LGR, like I did of Louis Rossmann. Yeah, it looks brand new. Like it has, I assume this is how you attach it to your CRT monitor. So you can make it an amazing touchscreen. There's some sort of adapter box here. So it talks about Windows 98. So would this be USB? Oh, it looks like it's, yeah, it's USB. Magic Touch. Oh, little icon of the hand. USB driver installation for Windows 98 only. You ever hear that theory on why they went from Windows 8 to Windows 10? It's because, well, this is just a theory. You have Windows 95 and 98, and so a lot of programs look for Windows 9X, so 95 or 98. And what I heard was Windows 9 would enumerate as the same OS in those conditions. Of course, if you're running software that old, who cares? Oh no, for Windows Me only, Millennium Edition. So we have two discs here. One is for Windows 98 only. And the other one is for Windows Me only, Millennium Edition. Oh, this must have been a big problem because they added a sticker to the manual. Only one disc needed. Your touchscreen will not work if you use the incorrect installation disc. I wonder if a modern computer would even find this thing. I mean, you know, Windows, that's one good thing about Windows. It's got like, 25 years of drivers built into it. Well, let's look at the device itself. This is where the magic happens. Again, this doesn't seem to have the original packaging, but other than that, it seems like it's unused. Huh. Is it... I guess we could look up the patent. Yeah, you would set these on the top of your monitor, bolted in place in one or two positions. Oh, it's even got little indents. That's nice. And then there's tape at the bottom, so it would be kind of like tape and gravity holding it in place. Oh, thank you, U.S. Patent Office. A touch-sensitive matrix switch assembly includes a pair of transparent insulating substrates having conductive row strips and column strips. Okay, so this is basically how your Nintendo DS works, or any cheap touchscreen, so it would be a single-point touchscreen. Are you ready? Are you ready for this? Windows was able to set it up. Oh my gosh, eTouch 1055. It's an input device. Oh my gosh. What is this, like 23 years old? Hey, you gotta say that for Windows, like this sort of stuff still works. Okay, are you ready for this? Are you ready for this? Watch. It actually kind of works. I can't believe it. It's actually not that far off. This is amazing. It's like, oh, when one touchscreen isn't enough, you have two touchscreens as an insurance policy. Oh my gosh, look. I don't know if you can see the dot on the screen. I think you probably can. It's not that far off. Oh my gosh. And I didn't even calibrate it. I'm amazed that this thing just works out of the box on a Windows 10 device. I thought maybe, I mean, I think it's kind of cool because it's quite transparent. You know, it doesn't have like kind of like the milky, faded look a lot of these touchscreens do. I remember, I miss the olden days where there used to be screws underneath the foot pads. Oh, it's in the middle. Those cheeky. Oh, wait, I can't say that on YouTube since it's now Veggie Tales Tube. All right. Looks like we have some Zener diodes. Oh, it's got an it's got its own chip, eTouch. What is this one over here? I mean, if I had to guess, oh no, I always say that, don't I? If I had to guess, it's probably a USB interface adapter and an ADC, analog digital converter. Wait, why am I using that when I could be using Goo Gone? Goo Gone. Come on, baby. Come on, baby. You knew it was time to just let go. But you wanna be free. Baby, you've just got to release me. So I want to figure out how this thing works, but I don't want to take apart the glass. Well, first of all, I don't think there's going to be much in it. Secondly, I don't want to break it or break the tabs. So I'm hoping this chip is not eTouch. Ah, crap, it's another eTouch chip. How could they have done this to me? You're tearing me apart, eTouch. There's one ground and then 5 signals going to some Zener diodes and some resistors and capacitors. I'm going to hook this thing up to my scope. This thing's probably about 23 years old, so I'm just going to briefly re-tin these pins. Something that can happen is there can be enough oxidation that just touching them with your probe isn't enough to get a good signal, so you kind of have to refresh them, get all that crud off of there. All right, let's probe around and see what we can find. Yeah, see how it's a little sticky? That's because of, you know, the corrosion. Looks like about, not quite 5 volts. That could be the power. Oh, okay. I was not expecting to see digital data on here. I thought it would be all analog. Interesting. I should probably write down my results. Look, there's a change when I touch it. That's interesting. What does it mean? It's interesting that the change is analog. Oh, maybe it is an analog signal, but it's being pulsed in a matrix. Okay, so now I'm clamped onto that pin. I'm going to touch the center of the screen and hold my finger there. I kind of doubt this is pressure sensitive. Well, I mean, technically it would be, because you'd have a, yeah, so you can see that rise and fall right there. All right, that looks, yeah, there's consistency to that. What is that? Well, you see, the values are lower than they were before because if you just let it go, you had something closer to 5 volts. It looks like it's this, yeah, it's the same pulse packet over and over. Okay, well, it looks like we've got 4 highs and 3 lows. And again, this is just one of the pins. I'm selecting all manner of things on my laptop, by the way. Hopefully I don't accidentally order any Adam Sandler DVDs. Yeah, can you see the waveforms rising? You know, I'm just going to touch the top. Oh, that's interesting. Oh, are they? I wonder if they're complements or inverse of each other. Dragging my finger down. Oh, it's weird. I can kind of, as I drag my finger across, I can kind of feel like bumps, kind of. Let's run it. I'm going to drag my finger to the left. Come on. Yeah, see one of the, yeah, see that one shrinking? All right, let's try this pin. What do we got? Oh, look, it's another waveform. Frequencies on all of them is the same, 1.562. Oh, there's that stair stepping again, but it's going in the other direction. Let's grab a stop of that. Interesting. Well, in the shock to no one, they do align. Yeah, it almost seems like this one is some sort of like voltage reference stair step. What pattern do we see here? Do you see a pattern? I'm still trying to find one. Okay, I do see one pattern in that. Oh, this thing even came with a pen, by the way. Keytech pen. So we have the 4 reference pulses, and they all appear to also reference the same value on the stair step, right? So you got the high value, high, lower, lower, lowest, high. So this high value matches up with that part of the stair step, and then the reference pulse that we actually saw change when we touched it, that aligns with the second stair step value. And then I'm guessing if I go to the other stair step signal, we'll see the same correlation, but in reverse, or inversed, I should say. Let's grab that. Stop. All right, come on, there we go. Happy little clouds. Yeah, see the correlation? So now you've got your 4, let's just call them, reference pulses. Now they're lined up to the highest point on the stair step, and your feedback is lined up to the second lowest point. So they are inverse of each other. I wonder if there's circuitry inside the glass. I mean, I didn't think there would be, but there might be. What's the width of these pulses? 200 microseconds? That's pretty slow. Oh, I know what I can try. See where the pulses are originating from. I'm going to unplug the screen from the USB controller. Oh, interesting. Okay, well that's a clue. So channel 1, that was the stair stepping channel. That's driving, and then channel 2, which I believe is horizontal, that's receiving. Okay, so why does it... Oh, by the way, I have my computer open, full screen of Notepad, so this will do as little damage as possible. I'm marking down what I find with the signals. It looks like the 2 positive pulses are on the left and the 2 negative pulses are on the right. It looks like it's acting like a 4-wire resistive. I actually had to look it up because I wasn't exactly sure how those are driven, but now I know. Let's look at the scope. All right, so this is positive number 2 and negative number 2. Okay, so in the scope right now, line 2 is positive number 2 and line 1 is negative number 2. See how they're inverse of each other? That makes me think this is being driven like a fairly standard 4-wire resistive display. So what they do is they alternate. They put 0 on one side and 5 volts on the other. And then on the other plane, they do a ADC test, so they can basically see at which point the voltage is being divided. So, like, let's say, it is still kind of weird that the pulses appear the way that they do, but I've got my finger on the left-hand side of the screen, and we can see these pulses have reduced. I'm not exactly sure why they look that way. And then if I go to the right, now we can see those pulses are high. So what that tells me is that, okay, so I'm going from right to left. So what I have marked as positive 2, negative 2 is the vertical plane position. So basically it puts 0 volts and 5 volts on either side of a plane, in this case, the vertical plane. And then when you touch the horizontal plane, that puts a voltage onto that line, and that's how you tell the position. And then you switch, you energize the other plane, and then you look at the resistive value of the plane you just looked at. Oh, I just thought of something. If it's alternating XY, XY, that's why we're probably seeing these multiple packets. So it's probably taking, looks like 6 samples plus a pulse at the end. And I assume it's probably averaging it or something. So each one of these is a sample of X and Y. I've got these 2 hooked up, and I didn't think this was a pair, but maybe it actually is, because when I touch it, nothing happens, which makes sense, because you can't complete a circuit on 2 things that are touching. But if you change it to 2 different planes, then when you move your finger around, it does change. 490. Hey, here's a brilliant idea. It's a 4-channel scope. Let's use all 4 channels. All right, let's do all the way to the right. Stop it. Yeah, see how channels 1 and 2 are more or less intact waveforms. And then you see stair stepping on 3 and 4. That makes me think In that case, 3 and 4 are acting as the measurement. So I think if we go vertical, we should see the opposite. Let's go left-hand corner, actually. Yeah. Same thing. Well, actually, no. Look, you can see that one changed. Look at that. Interesting. Maybe I thought about this all wrong. My life is a lie. Okay, so that's center of the screen all the way to the left. And we see it affected number 1 the most. So maybe number 1 is actually what we should use for H sense. Okay, so let's redraw this. Okay, now I'm going all the way to the top center. The center of the Tootsie Roll lollipop. That's weird. We're still seeing the stair stepping on 3 and 4. See, that seems to have affected channel 2. So let's try that. Let's go all the way down. Yeah. See how channel 2 now has high pulses there? So channel 2, which is on this pin, that would be the V-sense, which we actually did find in the previous tests. Yeah, we just alternate high and low on the 2 pins, and then we sense whatever grid is not active. That's pretty simple. Yeah, like in this pattern right here. This is the vertical sense low, which is at the top of the screen. So we see here on these waveforms, 4 is a high and 3 is a low, which means the top of the screen is vertical 0 volts and the bottom of the screen is vertical 5 volts. I think I can map this out now. Although I think I have my pairings backwards. Let me adjust this. I sped up the waveforms on the screen. So watch number 2 change as I go to the left and to the right. Then watch number 3 change as I go up and down. All right, I think I've got it. I think what I'll do is I'll take a snapshot of this and I'll pulse it the same way this control circuitry does. And that way we have whatever setup is happening in the beginning, because as you can see, there's some pulses where there aren't any changes. So I don't know if it's like charging up the panel or something. But I think we have enough information now to make this work with a driver. I desoldered the jack and wired up the most amazing Arduino Uno header the world has ever seen. And I plugged it into the Magic Touch. Code is really, really simple. We just have get V and get Y, and we just, do the inverse sense each time, as seen in this drawing here. And yeah, I noticed when you're not touching anything, it returns a 0 and a 1023. So basically, it's either all the way up or all the way down. So if it doesn't return those values, then we show active data. So when I touch it, we get a stream. You're probably thinking, why isn't Ben using his screen capture? Well, it's because I'm too lazy to go upstairs and get my headset. I used to have 2 nice headsets, but then I broke one. So now I just have 1. So this is lower left. Oh, I realize it's actually inverse. The second value is the H and the first value is the Y. So I'll just have to switch that around. It's crude, but it should work. So what can I do with this weird device, this touch screen that's quite transparent? Whatever I do, it has to be absolutely stupid. Okay, bud, get the laser. Look at the laser. What's the matter, bud? You don't like lasers? You used to love lasers. I will lure you into the laser zone with some greenies. Yes, you are now in the laser zone. Will he see the laser? Oh, he sees. Oh, what does he want? Does he want the greenies or the laser? This code is so janky, it barely works. But it's fun just to do something with a piece of Goodwill crap. Great, now I gotta think backwards. Oh, there's a laser! Oh, get it! Get the laser! Get the laser! What's wrong with you? Somehow he can detect when lasers are controlled by robots and he doesn't like them. You don't want the laser? Look! Laser! Laser! Come on, bud! Hey, bud, I got a joke about you and being needy. How many buds does it take to screw in a light bulb? 1! You hold it and the world revolves around you. Well, I'm sorry that Bud does not feel like chasing lasers today. Bud may not care about the laser, but it was fun to reverse engineer this piece of Goodwill crap. Although I think this was a pretty reputable company. I think they're still around. I think they renamed it to Tyco Touch or something. Yeah, so, if I put some more effort into the drivers, this might be kind of a useful thing. And it's pretty much a clear piece of glass. There's no coloring or distortion like you sometimes see with these resistive touch screens. So that's pretty neat.